Hey everyone in Calc BC. This is the first of many of the videos that I will be providing for you if you want to do a little bit of practice during our hiatus from school for a little bit. I hope you are all staying healthy and getting some rest and making sure we avoid large crowds. That way we can all stay healthy and get over this as quickly as possible. I did get an email from a couple of students in the BC classes wondering how to do a couple of problems here. This is actually number 12 from the absolute versus conditional convergence homework that we assigned on Thursday. And so yeah, let's just go over it and let's just see what you guys think of this problem here. And so this one here, they're asking us to apply what's called the ratio test for absolute convergence. Now, the ratio test for absolute convergence is rather unique among all of the absolute convergences. When we were talking about absolute versus conditional convergence, this one is rather unique, and I think you'll see why in just a second here. So let's go and just take the absolute value of this thing. So if I take the absolute value of this thing, one thing to note is that this series is really weird looking. There's a lot of K's flying around. But also the more notable idea here is that it's in is that there's this alternator here. And so when I absolute value this entire portion here, what's going to happen is the alternator is going to essentially go away. I'm going to look at strictly the positive terms of this series. And then what I'm going to do is I'm going to apply the ratio test on the absolute valued version of the series. So what does that look like? Well, that's going to be the limit as k goes to infinity of k plus 1 raised to the k plus 1 over k plus 1 factorial times k factorial over k to the k power. So let's go and break these things apart, and something cancels here that's not totally obvious. So let's just go ahead and break this thing apart. If you're moving too fast, it's very possible you could miss this this type of thing canceling here. That should be to the k, and this is k plus 1 to the 1 power, and realistically, because the bases are the same, you add the exponents. We've seen that movie before. I'm going to go ahead and call this k plus 1 times k factorial. I'm hoping we're all used to that by now. Times k factorial over k to the k. So how does this stuff work? So those guys are going to go bye-bye. These guys are going to make like a tree and get out of here. And we've got limit as k goes to infinity of k plus 1 to the k over k to the k. Now, if you're wondering where to go from here, clearly this thing it already looks like it's going to diverge. I mean, you know, the top is growing just a little bit faster than the bottom. But if we want to know like what number this limit actually goes towards, again, we're not talking about what the actual series converges to, but if we want to know what this limit goes to, it's kind of a weird algebraic manipulation right here. Because they're both being raised to the k power, I can go ahead and call them both to the k, and it's k plus 1 over k, using some cross reduction here, or some diagonal reduction. I'm going to go ahead and call it 1 plus 1 over k to the k, and I'm hoping that this limit is relatively obvious, like putting ice cream in the freezer. It goes to e. And so since we're not going to 0, since our ratio test does not, or rather, since our ratio test does not produce a value that is smaller than 1, sorry, I got my convergence test mixed up there. Since e is greater than 1, we can say then that that the series from k equals 1 to infinity of the alternation from k plus 1 of k to the k over k factorial diverges. Now, at the beginning of this problem, I talked about why the ratio test, or how the ratio test for absolute convergence was unique among the absolute versus conditional convergences. Now, normally, if this was the case, if we got the absolute valued version of the series to diverge, we would have to probably run a test on the alternating version of the series to make sure that it didn't converge conditionally. But the ratio test is actually unique because it comes back down to this portion of the problem right here. When you have this right here this is almost like, if we look at it like a geometric series, right? This would be, the inside would be similar to R, right? And in this case, if you can look at it really closely, the R is clearly greater than 1. And if the R is greater than 1, no matter what's happening, whether it's alternating or not, if this was a geometric series, you would be diverging, right? And that's why this sum from like this S sub n, which is a sub 1 times 1 minus r to the n over 1 minus r, this thing only becomes the sum of the geometric series if r, the absolute value of r, is less than 1. If you look at this guy, the absolute value of the r piece that would play the role of the r is greater than 1, so you know, whether you are alternating or not, you're definitely going to be diverging. So when it comes to the alternating, or rather, when it comes to the ratio test for absolute convergence, you really just need to test the absolute valued version of the series, and then if you get a divergent series, then the whole thing just diverges. Let me show you the next problem. And here comes number 21. Number 21, it's odd. It's a little too straightforward, I suppose, which makes me feel like you probably won't like my explanation for it, but I'm always open for feedback. If you were just to look at the first few terms of this thing, you know, what's odd about it is that the sign acts as the alternator, but not in a way that gets you something that alternates particularly cleanly. And so if you let k be 1, you get pi over 2, so you get 1. And then if k equals 2, then you get 0, and then negative 1, and then 0, and then 1, and then 0. So it looks like there's this oscillation effect that's going on. And so simply all you can say is that this thing diverges. And it's going to diverge with or without the alternator, because if there was no alternator, you would have just 0, 1, 0, 1, and realistically what happens is that the limit, the limit as k approaches infinity, now we're about to apply the divergence test on this thing, of sine of pi over 2k, I just like to see it that way better, has no limit. Limit due to oscillation. And then yeah, so that's it. Regardless of any kind of alternator or what, this thing's going to diverge by the divergence test. And all this mumbo jumbo right here, sine of pi over 2k diverges. Okay, so be on the lookout for some of these videos. I'll probably upload a few at a time. We'll probably start letting you guys, if you guys are interested, trying on your own some of these FRQs that we're going to upload onto MyConnect. So you'll see an announcement in a little bit. I'll probably post videos of me doing them in this manner every couple of days or so, or every Wednesday, and then we will, and then that way you can see how you're doing. Hopefully you guys are keeping your skills sharp, and otherwise, stay healthy, everybody, and we will see you hopefully soon.